All right, guys, so what we're going to be doing with rational expressions now is we're going to be extending them into situations where we need to multiply or divide them. So we might have two rational expressions or maybe even possibly three, and we need to simplify and then multiply them together. And the way we're going to do this is by just basically following the same steps as we have in the previous lessons. If you are simplifying, you're going to start by factoring, and then when you're done with that, you can cancel. But you need to factor completely first. So we're going to start with some pretty basic examples that don't have a lot of variables in them, like example A here. In example A, this would be a pretty easy one to do if we just wanted to multiply and then divide, right? So what would that look like? If I do this above, I'll have 20 times 3, 60, divided by 6 times 8, 48, and I can divide each of those by 12, then that's going to give me 5/4. Okay, so I know that this should end up looking like that. It should end up as 5/4. And that's a pretty easy example. We've got numbers. That's the way you should do it if we're dealing with just numbers. But I'm going to do it with factoring so that we can apply these factoring skills to rational expressions involving variables. So let's break these down first. 3 is already a prime number. I can't break that down any further. I can definitely break down the number 8, though. 8 is really just 2 times 2 times 2. And the reason I write it like that is because you've probably made factor trees before of numbers. 8 could be broken down a number of ways. You could do 2 times 4, right? But that 4 can still be broken down. So the best way to represent these, and just like when we factor, is to break it down to all of its prime factors so that you can't break these down any further. Like I can't break down 2's more than that. Otherwise, I just end up with a 2 and a 1, and I could just do that all day, right? So that's not helpful. But once I break it down so that it's just a product of prime numbers, that makes it a lot easier for us when it comes time to cancel. 20 is really just 2 times 2 times 5 if you made a factor tree of 20. And 6 is just 2 times 3. So those are all prime numbers there. The reason I'm going to write them like that is because now what I can do is I can write it. Remember, with multiplying fractions, I'm going to multiply my numerators and multiply my denominators. So I can do the same thing here with all these factors. I can just multiply my numerators and multiply my denominators. All right, and now I can just go canceling. 2, 2, 3. Nothing else will cancel here. So in my numerator, I still have a 5. In my denominator, I still have a 2 times 2, or a 4. So I did get that 5/4 that I knew I would get. This is the long way to do this if it's just numbers. Again, I think you should do this if we just have numbers. But we don't always just have numbers. Sometimes we have variables, right? So we need to have other ways to deal with this. And this is the concept behind how to deal with these. Once we get variables involved, it'll make more sense why we're doing it that way. In B, I've got a really difficult looking fraction. I want you to look at it like this, though. I've got a fraction on the top, which is this fraction, divided by a fraction on the bottom, which is this fraction. So really, it's like one huge fraction where the numerator is a fraction and the denominator is a fraction. You're going to see a lot of these. Just as a general rule of thumb, when you are dividing, all you are really doing is multiplying by the reciprocal. Excuse me, I'll give you an example of that. An easy example, just a very basic example, is if I had something like this. If I had 3 in my numerator and I had like divided by 1/10 or something in my denominator. 3 divided by 1/10 is a difficult looking expression to deal with, but if I rewrite it as multiplication by the reciprocal of the denominator, I'm going to keep my 3, but instead of dividing, I will multiply, and instead of 1/10, I'll have 10 over 1, because that's the reciprocal of 1/10, which is the same as 3 times 10, which is the same as 30. Now, I'm going to doubt that many of you would have seen this and thought, hey, that's 30. But when you rewrite it as instead of division, multiplication, and instead of the fraction in the denominator looking like this, it's reciprocal, now that multiplication is much easier to deal with. So it's kind of like how we'd rather deal with addition than subtraction. We'd rather deal with multiplication than division in the same way. So we'll apply that to b. I have my 3x to the 4th over 4. Instead of dividing by that denominator, I will multiply. And instead of 9x over 10, I'll have 10 over 9x. Now let's do the same thing we just did in a, where I'll just factor everything I can. So 3 is already prime. X to the 4th, I could write as x times x times x. I hope you don't do that again in the future, but just to prove my point here, I'll do that. 4 is just 2 times 2. And then 10 is really just 2 times 5. 9 is 3 times 3. And x is just x. So now what I've done just now is prime factorized everything. And you guys saw in the last example how I can just take all my numerators, make them one numerator, take all my denominators, make them one denominator, and then start canceling. I'm actually going to skip that step, and I'm just going to start canceling now, because I know that my numerator is really just all of that stuff up there. So I see a 3, I'll cancel that with a 3 that's down here. I see an x, I'll cancel that with an x that's down here. I see a 2, I'll cancel that with a 2 that's down here. And I think I'm out of things to cancel now. So when I put it all back together, I'm going to have 5x to the 3rd, because that's all the stuff in my numerator that didn't get canceled, and 2 times 3 in the denominator, which is 6. Okay, so we're starting to involve variables a little bit. And that's a situation where all of this can be done with just prime factorization, or really kind of like a GCF type situation. Now, we're going to start to deal with quadratics and higher order polynomials. So if I have something like this, remember my first step is in simplifying to factor. I got to factor everything that's here. The good news is I have multiplication. That's awesome. I don't have to flip and change that sign at all. But I have to factor my numerator. So my numerator is x squared minus 9. I'm going to double bubble that. My denominator is x squared minus 2x minus 8. I think that's going to double bubble to x minus 4 times x plus 2 times, these cannot be factored because they are linear functions. All right, now I can start canceling. In my numerator, I've got 3 factors here. 1, 2, 3. And in my denominator, I also have 3 factors. So I'll cancel any of those factors that I can. I've got an x minus 4 and an x minus 4. That's really just a 1. And I've got an x minus 3 and an x minus 3, another 1. So when all that cancels, I'm just left with x plus 3 in my numerator and x plus 2 in my denominator. And that's as simplified as I can get. I cannot cancel those x's. I've got to be pretty good at this factoring thing at this point. All right? Moving on to example D. Now D is a little different because we've got division here. So the first thing I'll actually do is I'm just going to rewrite this so I don't have division. X squared plus x minus 6 over x squared plus 3x minus 10. That doesn't change, but instead of dividing, I'm going to multiply, and instead of x plus 3 over x minus 5, I'm going to use the reciprocal of that fraction. Now I have multiplication, and that's great. So I can factor my numerator of that first fraction. That's going to double bubble. I'll have x plus 3 and x minus 2. And then when I factor the denominator, I'll have x plus 5 and x minus 2. And I still have times x minus 5 over x plus 3. All right. It's been fully factored. None of these can be factored further. So what I'm going to do now is just cancel anything that equals 1. X plus 3 divided by x plus 3 equals 1. And x minus 2 divided by x minus 2 equals 1. So that leaves me with x minus 5 over x plus 5. Those cannot be canceled. Do not try to cancel those. Those signs aren't the same. I know it's tempting, but you can't do it because that would have to both be an x minus 5 or both be an x plus 5. Some of you might think that you could maybe make this be an x plus 5 by factoring out a negative 1. So if you did that, you would have your plus 5, but this would then be a negative x. and that still would not cancel. So this does not work. You can't cancel that. Leave it as x minus 5 over x plus 5. All right? We're going to practice a lot of this in class, but make sure that you understand these notes videos before you come to class. If any of this was confusing, I would suggest going back and rewatching those confusing parts to make sure that you understand them and have some very good questions for the start of class, because I just want to practice. All right? I'll see you guys on Monday.